Hello everyone, my name is Kunal Sharma. I'm pursuing the BSc Honors in Data Science and AI at IIT Guwahati. Today I am excited to present my term project for course 3 DA377. My project title is How Trends Prediction System. Let's start with the problem that motivated this project. In major Indian urban hub, the residential rental market suffer from significant information asymmetry and subjective pricing. Property valuation depends on complex non-linear interaction between factor like carpet area, micro locality rate, furnished status, and city tier. Because there is no standardized benchmark, both tenant and landlord face uncertainty. The goal of this project is to build an objective data-driven machine learning tool that provide a fair rental estimate in real time. Let's move to the next slide. So to address this challenge, the objective of the project was designed to evaluate and deploy accurate machine learning regression pipeline. Our key deliverable include comprehensive data cleaning and exploratory data analysis, benchmarking multiple regression model ranging from linear regression to decision tree and random forest, pipeline serialization for production deployment, and a standard interactive Streamlit web applying serialization for production deployment and an interactive Streamlit web dashboard for real-time rent prediction. Looking at our data, the project uses a dataset containing over 4,700 verified rental listings across 7 major cities: Mumbai, Delhi, Bangalore, Pune, Hyderabad, Chennai, and Kolkata. During exploratory data analysis, two critical insights stood out. First, the target value, monthly rent, exhibit heavy right skewness due to high value luxury properties. To stabilize variance, I applied natural logarithm transformation, NP log 1p. Second, carpet area and local area rate square feet showed the strong positive Pearson correction less than 0.72 with the rent price. To prepare this data for machine learning, I structure a clean feature transformation pipeline, categorical feature like city, where one hot encoded dropping the first category to baseline pricing difference between metro tiers. Furnishing status was also a one hot encoded to capture the renter premium added by furnished versus unfurnished units. Continuous variable like carpet area and locality rate were scaled using standard scaler to ensure zero mean normalization across varying property size and high demand location. Discrete count for BHKs and bathrooms were passed through maintain structure layout constraint. For model selection, I started with multilinear regression and ridge regression as a baseline. I checked for a multicollinearity using variance, inflation factor. However, linear models struggle to capture complex non-linear location. Hence, I implemented decision tree and random forest regression. Random forest was selected because its bagging assemble approach handles non-linear feature interaction well, reduce prediction variance, and prevent overfitting on extreme luxury property outlier. Okay. So this is our here is our end-to-end architecture of the system pre-proposing. Pre-processing handles outliers, capping using IQR method and missing value input. Pipeline fitting builds column training random forest model. Model serialization saving fitted pipeline into model PKL file using joblib. Streamlit UI interact web dashboard for user interface. Now let's examine the experimental results. As seen, the performance comparison multilinear regression model achieved an R2 score of 0.59, 0.59 and decision tree reached to 0.72. Gradient boosting performed very well at 0.83. The top performance was the random forest regression, achieving a highest R2 score of 0.88. This performance confirms its effectiveness as capturing regional nonlinear rent patterns. To ensure our model generalized well to unseen data, I performed five-fold validation. Hyperparameter were tuned using grid search CV, yield optimization setting at n estimator is equals to 200 and max depth is equals to 15 using grid search CV. This optimization significantly reduced the mean absolute error, particularly for typical 1 BHK and 3 BHK apartment. To make the project practically useful, I deployed a model using Streamlit model caching applied Streamlit @sc cache decorator to load pre-trained pipeline instantly without disk read delay. Interactive UI built intuitive form input including city dropdown, carpet area slider, and furnishing radio button. Upon form submission, input vector are transformed and fed to the model to generate instant rent prediction in Indian rupees. In summary, the main challenge involved handling right skewed target value, treating high rent outlier, and standardizing varied locality rate across tier 1 and tier 2 city. Learning the project provide practical experience in constructing scattered learn pipeline, hyperparameter optimization model, serialization, and interactive web deployment. Future extension, looking ahead, this project could be expanded by integrating real-time web scraper for fresh listing, GIS mapping for rent heat map, and deep learning models. Let's review our project. Let's do a quick demo. So this is our main dashboard. You can change cities from the drop down, increase the number of bedroom, bathrooms, balcony, unfurnished area in square feet and area rate. So let's predict the value. Here is the predicted monthly rent for unfurnished flat in Mumbai with two bedroom, two bathroom, and one balcony. Area is 800 square feet. Let's conclude our project here. Thank you.